Hi, this is Irv Shapiro with Make with Tech. Recently, I had the opportunity to review the Anchor Make M5C, which is a wonderful printer in the sub $400 price range and includes some very advanced features. One of the advanced features is the ability to print at higher temperatures. Many sub $400 printers only allow you to print at about up to 230 degrees Celsius safely because of the structure of their hot end. The M5C goes up to 300 degrees Celsius. So that gave me the ability to print in one of my favorite filaments, which is ColorFab XT, but requires a print temperature of about 240 to 260 C. I generally print it at 250 degrees Celsius. When I first started to print the first sample, I ran into trouble. The infill looked terrible. It looked like the nozzle was hitting the infill. And I tried all of the tricks in my bag to correct that, and I'll talk about some of those in the video. But it ends up, it wasn't the printer, it wasn't the slicer, it was the filament. The filament had too much moisture. So let me tell you how I fixed that, which leads us to a discussion of drying your filament and also the proper way to store your filament. So stay tuned and let's learn something together. If this is your first Make with Tech video, let me tell you that Make with Tech is a collection of educational resources to help us learn together. It includes over 200 videos here on YouTube, many of them about this topic, 3D printing. It includes forum.makewithtech.com, a completely free place where you can exchange ideas with thousands of the viewers of these videos. It includes the website at makewithtech.com, and it includes models.makewithtech.com, where you can go to download various models I've talked about in these videos. Now, let's talk about filament and moisture. The style of 3D printers we're talking today are FDM 3D printers that use filament to print. Now, that filament is normally a form of plastic. And depending on the nature of the plastic, it may be hygroscopic. That means it absorbs moisture. Not like a towel where you'll wring it out and you'll see moisture, but enough moisture so that when you heat it up to a very high temperature to melt the filament so it can be extruded, that moisture will boil off. And if you've ever looked at a pot of boiling water, you see all those bubbles? Well, those bubbles will cause problems with extrusion and problems as you extrude the filament layer by layer. Now, there are two types of problems that I generally see with filament that has too much moisture. And we'll discuss what too much moisture means in a minute. The first problem that I see most commonly is the prints just look really bad. There are gaps, there are holes. Well, you can think about it. If you have moisture bubbling out, that's not going to lead to a smooth bead of filament being extruded. And in many cases, when you extrude filament with moisture, it doesn't lay flat on the extrusion. That causes the problems we see here. So if you see really ugly infill, you should check the basic things first. Make sure your print bed is properly leveled. Make sure the distance between the nozzle and the print bed is correct. That's often called the Z offset. Even though Z offset as a term means something slightly different, adjusting your Z offset will adjust the distance between your nozzle and the print surface. Make sure you're printing at a high enough temperature. If you print at too low of a temperature, the filament will not spread out properly when it hits the print surface or when it goes layer to layer. Make sure you're not printing too fast. You can make sure the flow rate in your slicer is correct. Those are all things for other videos. But in fact, if the infill and the first layers look like this, you should check the moisture level of your filament. Now, how can you actually check the moisture level of your filament? Now, one way to measure the humidity from your filament is to measure how much humidity it's releasing into the atmosphere. Now, you can't do that in the room, but you can seal your filament into a bag and then put a meter in there, and you can get these online. I bought these from Amazon for a couple dollars each. That will tell you the humidity. Now, they're not absolutely accurate, but they'll give you the right ballpark. So in this particular case, this is PETG. This happens to be Prusa PETG. And it says the temperature inside this bag is 71.6 degrees Fahrenheit, and the humidity is 33%. Now, I can tell you the humidity in the air here is about 55%. So that says that this filament is drier than the surrounding air. And in fact, under 40% is okay. Under 20% is really good. Under 10% is fabulous, but you're probably not going to get that unless you print directly from a print dryer. And we'll talk about that in a minute. Now, when you print, the nature of your filament will determine how much humidity is acceptable. PLA, which is really the go-to filament for many people, works really fine at under about 40% humidity. And in fact, your prints may still look okay if the humidity is higher. But what will you see? You'll see two interesting phenomena. The first is the filament will be much more brittle. If you have your filament breaking in your Bowden tube or breaking as it's coming off the reel, check the humidity, the moisture level in the filament, and think about drying it out. And if you're getting a lot of stringing, it may be retraction, temperature, other things. It may also be moisture level. Now, in other filaments like nylon, if their moisture level is really above 20% plus, you're going to have trouble printing with them. The adhesion between the layers is not going to be proper. It won't stick on your print bed. Overall, the prints are going to look terrible. So how did I diagnose this problem? Well, the first thing I did is I happened to have another reel of ColorFab XT, and I went to print with it, and it was just fine. So then I thought I'd dry out my reel of ColorFab XT. And at the time, I was using this particular print dryer, which is made by a company called Eibos, and I was a little naive. I set the print dryer to 70 degrees Celsius because this print's at a relatively high temperature, and I went to dry it. And I left it overnight. And I came back, and I had a block of XT filament. This is no longer usable. You can't get it off the reel. Some of it's loose, some of it's all stuck together. So the first rule is dry your filament at the lowest temperature possible. So most of the print dryers start at 50 degrees Celsius. It ends up that PETG, which this is a variant of, should probably never be dried at above about 55 degrees Celsius. The only filaments you really dry at a much higher temperature are nylon, but they also print at a much higher temperature. Now, what is the right temperature to dry it at? Well, the first thing you want to know is what is the glass transition temperature of your filament. And you can look this up online for any filament. What is the glass transition temperature? It's when the print the filament goes from being rigid to rubber-like or putty-like. It's not melted, but it's when it gets soft. At that temperature, the filament will also begin to stick to itself. Now, the glass transition temperature of PETG is actually 85 degrees Celsius. The glass transition temperature of PLA is 60 degrees Celsius. Now, PLA we normally dry at 50 degrees Celsius, so about 10 degrees less. So 10 degrees less than PETG would be 75. That shouldn't have been a problem. That leads us to the next thing you have to check on your print dryers. And that is, what's the actual temperature it's drying at? And it's not uniform in this enclosure. With a smaller enclosure like this single filament dryer from Sunlu, then it's probably likely it's more uniform. But in these larger enclosures, what I found by measuring temperature a lot of different ways, including putting a sensor right in the middle, including using a thermometer at the top, at the bottom, is that the temperature can vary by 10, 15, or 20 degrees Celsius. That's a lot. And so in this case, this print dryer from Eibos, and this is an old model, so I'm not reviewing it. I'm not comparing it to their current model. But this particular one, in general, was running about 7 to 10 degrees hot. That was enough at 70 degrees to cause me problems with my PETG. So since then, I've been very conservative, and I've been drying everything at 50 to 60 degrees Celsius, and don't dry it longer than the print dryer recommendation. Now, let's look at these different print dryers, and we can see the characteristics. Most print dryers have the ability to run the filament directly out of the print dryer and connect it somehow or another to your Bowden tube or directly put it at your extruder. And that allows you to keep it dry the whole time it's running. Now that's very important for something like nylon. For PLA and PETG, I haven't found that necessary, but it's a nice feature to look for. The next feature to look for is the front panel. In this older Eibos Cyclops version, the button, the push panel, wasn't great. Another feature to look for is an indicator of the current temperature and humidity. In this case, it was a separate indicator. And I've used this print dryer very, very successfully for quite a number of years, normally though at the lower temperatures. Now, one of the print dryers I really like is this Sunlu print dryer. What I like about it is it's very compact, it's very easy to use, it's easy to stick next to your printer. It has a very sophisticated front panel. This front panel requires you to double tap this button, and you have to get the frequency just right. But once you do that, the controls here are very, very nice. It has defaults for different filaments, so you can just select your filament and it will set the proper temperature and duration. So you can see here, if I set this to PETG, it's recommending a set temperature of 50 degrees Celsius. Currently inside it's 29 degrees Celsius and 53% humidity. Now, one of the things I did look at on these various devices is how low could it pull the humidity down. This one went down to about 15 degrees Celsius. These two larger models did go down to about 12 degrees Celsius or less, and so that is a slight advantage for them. This particular print dryer here is from Fixdry. It's a new model. They recently sent this to me in order that I can do these tests, so it was a free sample for the review. It has also a nice front panel. I don't know if you can see that here. And you can cycle through the various options here on the front panel. It works quite well. It's a simpler display than the Sunlu. One of the limitations of this print dryer is the structure. These sit in on rollers here, which are quite nice, but they were a little too narrow for the Prusa reels of filament. Whereas the Eibos was able to handle the Prusa and the Sunlu was able to handle the Prusa. The overall fit and finish of this device is really quite nice. And they have an interesting feature here they have a little deflector that they recommend you use when you're not printing directly from this device to keep the hot air from hitting the reels directly. And it might have been that the hot air directly hitting this reel was why the 70 degrees Celsius impacted this print. All three of these print dryers work effectively. The nicest display is this one. This is the most compact. This is a very modern interface and display. The display works, the controls work well. This Eibos I really can't comment on at all because it's a couple-year-old model, and I'm sure the new models are quite different. In terms of temperature, all of them were somewhat variable. The Fixdry ran a little cooler than the set temperature. The Eibos ran hotter, which is more problematic. The Sunlu was the closest to the actual set temperature. In terms of price, the current model of the Eibos is dual reel filament dryer is $120. The Sunlu was $70 for a single reel. They do make a double reel model. And the Fixdry was really a good value at $93 for a dual filament reel model. Now, you've dried your filament. If it's nylon, you're going to print right out of your filament dryer. If it's not, you're probably going to take the reel, you're going to put it on your printer, and you're going to print. That's great. That won't cause any problems. But let's say you let it sit there, in my case, in my lab environment where it's about 60 or 70 degrees humidity, for a couple months, or even a couple years, like this reel. And then when you go to print, you're going to have stringing, you're going to have bubbling, you're going to have layers that don't look right, and in some cases like PLA, it's going to be brittle. Does that mean you have to re-dry your filament every time? Well, it wouldn't be a bad idea, but that adds hours to the preparation time. So an alternative is to seal it with some desiccant, which are these little blue packets, in a sealed bag. And that will keep it pretty consistent for a much longer period of time. Well, how do you do that? Well, the product that I've been using is from eSun. And I buy these on Amazon. They sell two versions. One version where you get the bags and desiccant, and you get a hand pump. So basically what you do is you take the bag, you put a reel of filament in it, you press the pump down. Let me get this out of the way so you can see. You press the pump down on the seal, the little blue seal, and you start pulling out the air. Now, that absolutely works. It takes a long time. It's no fun at all. Now, the irony is, for literally $5 or $6 more, you can get a package of these from eSun that also has a power vacuum unit. So in this case, what I do is you take a reel of filament. This happens to be TPU I recently dried. You put it in the bag. And let's see if I can add a packet or two of the desiccant. And what is desiccant? Desiccant is a material that's been dried of all moisture that tends to absorb moisture. It's like super filament. So it absorbs moisture, and therefore, if you put it in with your filament, it will pull some extra moisture off the filament. In this case, the version of this desiccant that you get from eSun, it turns red or pinkish when it's absorbed moisture. So you can throw a couple of these in, and I don't know if it really matters where you put them. I put one on the outside, one on the inside. Then you seal the bag. Now, you can attempt to seal the bag by hand, but I found that doesn't really work very well. and they'll leak air in. So instead, they give you this little sealing tool that you run over the edge and you use it to seal the bag. And I do that a couple times. Make sure it's good and sealed. Then you take the electric pump, you put it on the air valve, you press down, and you turn it on. And you're gonna see in a second the air being pulled out of this bag. Now, this is gonna take a couple minutes, and it does a really, really good job, and it's painless. So a set of, I think, 20 of these, let's see, I had a little note here by myself, a set of 10 of these bags with the pump are $22. 8 bags with the manual pump are $15. Are there alternatives to this? Yes. You can just take a big plastic bin that has a good seal. You can buy these at your home center sort of store. You can put a larger desiccant in there. There are many brands of desiccant, and you can store all your reels of filament in those bins. The key is that you need to store it after it's been dried to allow you to use it immediately when you go to print next. So folks, in conclusion, if you're getting terrible looking prints with lots of where it looks like the nozzle is hitting the surface of the print, that could be caused by too much moisture in your print. Because here's what it looks like when you print on the same printer with the same filament that's completely dry. I hope you learned something today. You learned about filament dryers. You learned about storing your filament either in bags like this or in bins with a large desiccant. And if you did, please give me a thumbs up, subscribe to the channel. I always encourage you to go to forum.makewithtech.com and join the discussion. And folks, let's continue to learn things together.